Hello, my lovely viewers. Let's take a quick look at this question. This question we are asked for the equilibrium reaction. This is the equilibrium reaction. Okay. Increasing temperature will do what? Increase N2O4 formation, increase NO2 formation, have no effect, and will stop equilibrium. Now, firstly, what I want you to understand is look at the equation. Just know that this equation is what? An equilibrium equation. And now, according to Le Chatelain, that there are three major factors that affect chemical system in equilibrium. One, we have temperature. Two, we have pressure. Three, we have concentration. We have extensively discussed concentration in our previous video. Just go to Ojemai, look at Ojemai TV. Just type the effect of temperature or effect of pressure or effect of concentration on the chemical equilibrium by Ojemai. So it will give you that video. Now, if you look at this equation, look at the enthalpy change. This sign is what? Enthalpy change. And the enthalpy change here is what? Negative. Since it is negative, just know that this equation is what? Exothermic reaction. Means that heat is being what? It is being released into the environment. Anytime heat is being released into the environment, it means that it is what? It is exothermic reaction. And Le Chatelain says that in effect of temperature, there are two things that you need to know. One, endothermic. It is either a reaction is endothermic or what? Exothermic. But here we are given what? Exothermic. And in exothermic reaction, exothermic, where heat is being released, if you increase temperature in exothermic reaction, the equilibrium will shift backward. Do you understand? The equilibrium will shift to the what? To the backward reaction. That is the left hand side. Equilibrium will what? Shift backward. Look at the arrow that indicates this one is forward, and this one is what? This one is what? Backward. Look at the backward reaction here, and this is what? Forward reaction. Forward reaction, backward reaction. This is the right, this is what? The left. Now, if you increase temperature in exothermic, the equilibrium will shift backward. Look at the arrow here. The arrow here is pointing this side. So if you increase temperature, the equilibrium will what? Will shift towards this side. If you decrease temperature in exothermic, the equilibrium will shift forward. Do you understand? It is different from endothermic. In endothermic, if you increase temperature, the equilibrium will shift to the right. That is, the forward reaction is what? Favored. You understand? But now they are asking us of what? Of exothermic reaction. So if you increase temperature in exothermic, the equilibrium will shift to the what? To the left. That is what? The backward reaction is favored. Look at the backward reaction. Look at it. This arrow is pointing this side. It means that in the which one will be, look at increase in what? Formation. No, this one. Look at the one. If that is pointing like this, it would have been increase in this. But since it is pointing like this, it means that it is what? Increase in what? Nitrogen 4 oxide. You get that? Look at nitrogen dioxide. Look at. So this one will be what? Favor. Our answer is what? If you increase temperature in exothermic reaction, the equilibrium will shift backward. If you decrease temperature in exothermic reaction, the equilibrium will shift forward. But in endothermic, if you increase temperature, equilibrium will shift forward. If you decrease temperature, equilibrium will shift what? Backward. But this one we are given what? Exothermic. It means that if you increase temperature in exothermic, equilibrium will shift backward. Shift backward. Look at the backward reaction. We shift this side. You understand? And this is a sign for you to know that it is exothermic because of what? The enthalpy change here is what? Negative. For more of this video, do well to like this video, share and comment. Do well to follow this page for more of this update. Thank you and God bless you.